In this video, we are going to review for chapter we have 8.5, which is the complex numbers. So what is a complex numbers, by the way? So we have complex numbers is a combination of a real number and we have an imaginary number. So just real numbers can be represented by points on the real number line. So you have represented by z is equals to a plus bi. So a is the real number and bi is a complex we have number. So in the graph, we have the horizontal axis is called we have axis or the real, we have real numbers, and then we have for y, so we have for the value of y here is the imaginary axis or represented with we have y values. Okay, so how will we graph now complex numbers? So to graph complex, we have numbers. For example, given a plus bi. To draw the graph of this given, a is the real numbers. So this one will represent the real numbers and this one will represent the imaginary values. Example, z is equals to 2 plus 4i. So we have 2 points from here for the value of real numbers and 4 going up for imaginary. So this one will be our first point. Let's say this one is point A. Let's say this one is point A. So next is point B. Z is equals to, let's say, negative 3 plus 5i. So in this one, we have negative 3, 1, 2, 3. And then 5i, so it's in this quadrant. So therefore, we will have this point, which is point B. And then what if we will have z is equals to negative 5. So here, as you observe, there is no value of a complex number. So therefore, we can have that one as negative 5 plus 0i. So if we will draw that one in the graph, so we'll have negative 5 for the real number, okay, so, and then 0 for I. So therefore, this one is a point C. So this one is our point C. And then, for example, we will have point D, which is the given is equals to, let's say, negative 3i. So where can we find that? So that is also equals to 0, which is the real number, plus, or we have minus, okay, minus 3i. So we can find that one in this line, the 0 for real numbers, and then we have negative 3i. So this one is here on this graph. Okay. How will we solve now the absolute value of a complex number? So going back to our lesson 8.5, absolute, we have value of complex numbers. Z now is equals to the absolute value of a plus bi, which is equal as well to the square root of a squared plus b squared. For example, z given 5 plus 3i. So where can we find this? We have points. So it's in quadrant number 1 because both given is positive. So therefore, we will have now 1, 2, 3, 4, 5. 1, 2, 3. So therefore, here we will get this point, which is this one here. So how will find how will find the absolute value? So therefore, we will get now 5 squared plus 3 squared. Okay. Therefore, we will have 25 plus 9 square root equals to 34, so square root of 34. If you can simplify more further, so just simplify it in the simplest form. Another, for example, given z is equals to 4 minus 7i. Okay, so where can we find this? We have point. So this point now is in quadrant number 4, which is the positive and a negative sign. So to find we have the absolute value, we will get now 4 squared plus negative 7 squared for the square root of this value. 4 squared is equals to 16 and then plus 49. So how much we have? That is square root of 65. Can we simplify it further? 65. So that is, we have the simplest form of the absolute value of a complex number. Okay, next. What is the difference now between we have the rectangular form for a complex number and the polar form, which is the trigonometric form of complex number? So in rectangular, the given are a and b. In the polar form, we have r and the theta. And it's in the form of z is equals to a plus bi, or we can have now equal to a squared plus b squared. Here, we can have now in the form of z is equals to r times cosine, we have theta plus sine theta. For example, we will solve z, okay, example, z is equals to 1 and or 1 plus I. Make it in the form of a polar form, or in a trigonometric we have form of a complex number. So therefore we will have now to find first, or we have to graph first. Okay, so this one is in this. Okay, so this one is in this quadrant. So let's make a little bigger, 1 and 1 as well for I, right? Theta. And then also we will have the r. Now, how will we find theta? So to find theta over here, or we have to find first r. How will we find r? R is also equals to the magnitude of z, which is equals to the square root of a squared plus b squared. Okay, so remember we have to solve by the use of Pythagorean theorem, which is c squared is equals to a squared plus b squared. From here, given I is, or the coefficient of y, I is 1, and then we have the value of the real number is equals to 1. So therefore, the r now is equal to the square root of 1 squared plus 1 squared, which is equals now the square root of 2. How will we find the theta? Remember solving trigonometric functions, which is SOH, CEH, and we have TOA, which is the sine opposite over hypotenuse, cosine adjacent over hypotenuse, and tangent is equals to opposites over we have adjacent. So therefore we can solve now. Theta is equals to arctan, okay, 1 over 1, which is equal to tangent, or tangent to the power of negative 1 equals to times 1 will be 45 degrees. So therefore the given angle now here is equals to 45 degrees. Now we'll write in the form of polar, or we have in the trigonometric form. So therefore we will have z is equals to r is equal to square root of 2 times cosine 45 plus sine or I sine 45 degrees. Okay, so here you can write in this form, or you can write as well in radian form. Square root of 2 times cosine pi over 4 plus I sine pi over 4. Okay, next example, let's see. Okay, for example, we have, let's say, okay, for example, given z is equal to 2 minus, we have 2 square root of 3i. So which quadrant this one will lies on? Okay, so therefore this one is positive 2. And then 2 times square root of 3 is approximately, we have 3.5 or 3.4. Therefore we'll have 1, 2, 3. But this one is negative, right? So therefore the graph is here. So this one is 2 square root of 3 and this one is 2. How will we find the r? R is equals now to 2 squared plus, we will use 2 square root of 3 squared and then you square that one. So therefore we'll have 4 plus 2 times 2 is equals to 4 times 3, so therefore we'll have 12. This one will be square root of 16, which is equals to 4. How will we get the theta? So tangent negative 1 is equals to, or we have this one is for theta, right? Theta is equals to the arctan of opposite over adjacent. So this one is our theta over here. So we'll have 2 square root of 3 over 2. Cancel out the 2 there. So therefore we will have tangent negative 1 times square root of 3. Be sure that your calculator is in degree mode. So therefore we will have now that theta is equals to 60 degrees. But the 60 degrees there is our reference angle. So this one is just only the reference. So we will have to find how much is this one. So therefore we will have now that theta is equal to 360 minus the given theta or the reference angle, which is 60 degrees. So therefore the given theta now is equals to 300 degrees. So to write that one in, we have trigonometric form. So we will have z is equals to r times cosine theta plus I sine, we have theta, that is equal to 60, or no, we have our r is equals to 4 times cosine 300 plus I sine 300 degrees. Okay, so when you have to simplify it more further, same, what is cosine? You have to do cosine 300 plus sine, and then you just distribute this value so that you can get what is the real or actual amount of that. So if you get it, so that's all for this video. Hope you learned something. If you have more questions, you can just comment in our comment section of our video. Thank you so much and have a nice day.